Mic is on. All right. Okay, so there were some changes to the big matrix. Let me just bring it up. Yep, and I have to reallocate some of the people for reviews and for counter arguments, but hopefully everybody has the essays and the tasks kind of settled. So if you just double check the matrix on Fronter, you should see that for some of your reviews and counters, you might have been reallocated to a different essay because we didn't got all the essays, right? So there was one person sort of not submitting an essay, so we had to recycle some of the people who did submit, and there was one missing. So for the one missing, we will use the discussion that we had on conversational agents, and we will basically counter argue and review the essay that was written by what was his name, Thomas Tunguts, right? So there was an online essay that we discussed like last week, and we used that essay as an essay for review and counter instead of the one which was missing. I think it's kind of okay because the essay was, I mean, we discussed that essay last week, and it is possible to kind of counter it, and it's also possible to, yeah, to review what's strong and weak points of that essay. So that should be fine. So we use that one, and we have all the articles in. Is there anything missing? Is there anybody who doesn't have an essay to review yet? Yeah, we're just discussing small changes to the matrix on Fronter because we had one essay which wasn't submitted, and we had originally one essay which wasn't written. So we're using the again, what's his name? Tomasz Tungut's essay for the reviews and counters. So you will actually do the multimodal interfaces. Is that okay? I think that's fine. The essay is it's reasonably short and it's okay to review. Yeah, and then everybody should have the articles and everybody should have the reading materials and the essays already on the drive. So how you guys doing with the writing? I've seen Håkon doing some work. Anybody else wrote the counter arguments already? Reading the essays? Yeah, that's fine. I think by reading the essays, you kind of get a good, gentle introduction to the papers, and then you can follow up by reading the papers, right? So most essays are actually pretty good. We didn't have essays last year. We had the writing a report on the topic, right? And to be honest, it's kind of very similar to the essays that you guys written. It's even better, I would say. It's more concise. So it's a really good idea to read the essays first, and then if you need more details, go to the papers. But you get almost, a very good summary in the essays. So people did pretty good job, I would say. So that's let me see when we have the. So we have another 3 weeks, right, for the reviews and counter arguments, and then we will have the follow-up. Yeah, so after the deadline, we can kind of discuss it. We will not have a lot of time to discuss the reviews and counters, but as I said, if you if we get something for an essay, like if we get all the reviews for that essay, we can publish it earlier, right? Because we're not publishing only for not biasing the other reviewers, right? So normally when you review for conferences, it's the same. You don't see anybody's reviews until you submit yours, and then once you submit yours, you can see what other people said, but you don't read what other people say about the article or an essay before you formulate your own opinion. And then you may change your opinion, right? So if you really dislike the paper and the other reviewers liked it, and you read their reviews, maybe you kind of change your mind a little bit. Maybe they point out kind of a good sides of the article. Or often is the opposite. So you like the paper, and then some other reviewers argued against it, and then you sort of have to write a short comment, right? So normally what happens in the conferences is you get 3 reviewers reviewing an article, and then there is a kind of a process of reviewers reading each other reviews and kind of settling down to some sort of a common ground, right? So if you have 2 strong against and I'm for, I have to sort of say something or change my for against, right? So it's kind of there is a bit of a conversation going on after the reviews to balance it off. So if everybody is kind of in the middle, then that's okay. But if there are strong opinions, then you sort of need to argue for the opinion that you had or change it. You can change your reviews after reading other people's reviews, right? So I almost always there is a discussion, and almost always there is a variety, right? And I've seen reviewers changing their reviews based on my review sometimes. So I pointed out some good points about the article, and then they were strongly against it, but then they bumped it to kind of being more moderate. So it does happen. We don't formally give grades, and we don't score, but I was thinking if, apart from the review being, so normally what happens is in some of the conferences you have your review, so it's just a text that you say about the paper or the essay, and then usually you have to say confidence, right? Confidence. So how confident, how expert are you in that field? So how strongly your review should be taken into account when judging that paper. So if you're an expert in the field, you say, yeah, I'm really confident. And if it's the field which you're not really familiar with, but you can judge the paper or the essay on the merits of readability, consistency, argumentation, and so on, but not on the actual, like, the article to you may sound really good, but it might be describing things that people in the field know for 20 years, right? And then it's not very good paper, because it sounds on the surface it's a good paper, but it presents something that is obvious to everybody in the field, and therefore, it's not a great paper. But because you're not an expert in the field, you may not know that, right? You may not know that the problem they discussing is actually trivial or already solved or not interesting, right? So if you say I'm kind of not confident, then it's okay for you to like the paper, but the paper to be rejected. But if you kind of have strong confidence and you say, yeah, the paper should be accepted or rejected, it's kind of taken more into account. So the next one is, reject all the way to accept, right? So sometimes you just have reject or accept, sometimes you have something in the middle, sometimes like, neutral, sometimes you have weak reject or weak accept. So it's sort of usually a scale, and you basically say whether the paper should be published or not, right? Well, in the last few years, when I am reviewing and reading papers, I almost never get to hear. Unfortunately, I kind of happen to read not as great papers, right? So it's usually either somewhere in the middle, or kind of the paper is good but needs some more work. So it's sort of somewhere here. you need to develop that. So you need to read enough papers to know which papers you would consider really good and which ones are completely, not good. Because if you read just one paper, it's hard to say where it falls, right? But in your case, you will be reading a couple of essays. So I think you might get kind of a feel of what you like and what you feel other people should read and what you feel should be improved before other people read it, right? Because you're kind of making an expert opinion, an expert statement, suggesting other people reading it or not, right? You kind of like, it's your fault if you make paper published which is not worth reading, right? It's kind of your responsibility to prevent that. And also it's your responsibility to spread good papers around, so to argue for good papers to be published. So I was wondering if we should have something like this, or maybe a scale like you may have 0 and 5, right? Which reflects, okay, that was very, very good. That was like really, really bad, and somewhere in between, right? So 3 or 2 being kind of yeah, it's sort of okay, but not super great and not very bad, right? So we could add that. So how confident you are in the field, and well, for most of the topics you should be kind of the same. Like you're not a super expert in the field, but you read a couple of papers and you sort of know what is it all about. So I'm not sure this is that relevant, but I think that might be a kind of a good exercise for you to critically consider whether you would accept or reject a particular essay, right? And kind of and why, right? So usually you have to argue that. So if you say, oh, strongly accept, you have to say why, why it's so good, right? And if you say strongly reject, you also need to say why. Even for rejection, you need kind of more work, because people put some work into it and they did some research and they did the work and have the paper written, and now you're saying it's crap, right? But you have to explain why you think that, what is missing, what they need to do to improve it, what was is it like fundamentally flawed, like this experimental setup is so bad that it's unrecoverable, that you cannot do anything with it, or whether they are missing some things, missing some key publications in the area or whatever, right? So it's kind of your responsibility to make sort of an argument for the decision that you're making. And it's quite fun, because you can express your opinion in a civilized fashion and have an impact of what happens, right? So that's how scientific sort of endeavor works, that people discuss things and people argue and people say, okay, that should be done better because you have some limitations, or you didn't take some confounding variables into account, and so on. So you can point out some things, and the people who, even if you reject the paper but provide kind of a good arguments, that's very valuable. That's a valuable feedback for your research, for their research, right? And if you on the other end and you receive a rejection with a good explanation of what's missing and what was wrong and how it could be improved, it's great, because you can kind of do those things, you can follow up, right? But if you just get a reject, it's not that great. And often if you just get an accept, yay, your paper is accepted, but it's also good to know why. It's also good to know what the reviewers liked and what they paid attention to. And sometimes it might be different things to what you're paying attention to, right? So providing kind of a feedback and explanations for the decisions people make is valuable even if it's a reject. So even if you wrote an essay and some people think, yeah, well, it wasn't the greatest, then if they tell you how you could have improved it, that's great. That's a lesson you can sort of take on board and add or change your essay and make it better, right? So that's the whole point. So I'm thinking maybe we should we kind of do a little bit of that. So you should just pretend it's a kind of a review for publishing those essays, and whether we should publish it or not, whether it's it kind of tests the threshold of what you feel is worthwhile that everybody should read, right? And we all aim at doing that, but if we didn't make it, then try to explain why that particular essay didn't make it. What was missing in that essay that it didn't make through the threshold. Do you feel it's okay, or do you feel it will be impacting you negatively if somebody says reject on your essay?
The thing is, the opinion will be based on one paper. So we will read the paper and then read the essay. So
that's right. Yeah.
Does that make us
experts
in that?
No, so that's what I'm saying. Yeah,
it will be read the paper, and then if everything from the paper is kind of put it in the essay, then it's okay. What else you can
exactly do? Yeah, exactly. That's what I'm saying. That it's sort of a mini game, because we're not really taking into account the whole field. We're just taking an example of just one paper, one or two papers, and we kind of pretending that we experts in that sort of one or two papers, right? So it's not a very solid argument. It's just kind of pretending that we sort of trying to do that for the sake of the process of how it is done. So I would say the accept or reject doesn't mean that much in this case, because it's kind of a very narrow. Yeah. All right. So, oops, sorry. So what we have today is we have only Martin emailed me that he would like to talk. I don't. So what we can do is we can discuss. We can let Martin present his essay, and provide some feedback.
Could you also, after Martin is finished, could you show some examples of doing the review and the counter?
Yeah, we can discuss that. So I wanted to do that as well. So if people have reviews or counters already written, like we talked with Popon, and he sort of has an example, we can discuss your one, how you kind of did the.
I don't know.
You had done. Okay. Right. Yep. So we could discuss that, how to do this. Yeah. Yeah.
I think we need to turn it on. No.
It's on.
Okay.
Yes, it's alive.
Yes. Yes. Okay, so my topic for this course is mobile cloud computing. So in this presentation, or short presentation, I'll go through what cloud computing is, and sort of give you a taste of what mobile cloud computing actually is. I see that I forgot to update my outline. However, I'm first going to talk about the current challenges in today's architecture and the development of mobile applications and applications in general today. And then I'll dive into the definition of mobile cloud computing and sort of dig into that and try to explain that to you. And then I will sort of look into what this kind of changes, and then I'll look into the arguments that I present in my essay. So, the paper talks about something called heterogeneity in computer systems, and that means that you have several different types of devices together in one system. So, for example, if you have a heterogeneous data center, you can have a data center with many different servers. And if you had a homogeneous data center, you would, on the other hand, have just one type of server in that data center. And today, we sort of have this affecting in both mobile and networking and in the cloud environment, where on the mobile, we have a ton of different devices. We have different screen sizes, we have different resolutions, different processors, different architecture, different platforms, and also different versions on absolutely everything. And that's sort of what this figure tries to illustrate. That we sort of have to know about all of those different things. And you also have this same problem sort of in networking as well, where you have, for example, you have Wi-Fi and all the standards there, all the various speed versions, standards, and all of those things. You also have the various networking standards and all of those things. And you also have the same thing in the cloud, where you have different architecture, you have different services, and you have different standards, and so on and so forth. And when we are making our applications, it gets complicated because we have to know about all of these different things, and we have to pick one. And normally we go with the one that we feel is the best and the one that we are sort of most confident with and know how to use, so we can actually implement things with it. However, if we were to support, for example, several mobile platforms, it can quickly become sort of painful, since unless you start using cross-platform frameworks such as Cordova or Xamarin or something like that, you sort of want to make your application native so you can use the APIs that's provided in the operating system directly. And for example, I want to make an app that's it's a game, for example. And then I make it for Android first, and then I might start working on iOS, and the game itself might take 3 months to implement. And then when I'm done with that, I have to start all over again on iOS, the new development environment, new language, new ecosystem. Everything is absolutely new, and you have to sort of dive into the exact same things as you did in Android all over again. And you sort of have this process going on, and it's quite expensive, since you also have to support the Android application while you're working on the iOS application. So it's taking several months, maybe even more if you're not familiar with iOS. And that is sort of a problem that's also discussed in this paper. And on the cloud side, you also have sort of the same problems. However, there you normally go with just one service. However, on the other hand, there you easily lock yourself to one specific provider, and it's quite inconvenient to switch, for example, from Azure to Amazon if you have tied yourself specific to that cloud vendor. And that's one specific problem with cloud technologies today. And another one that's also discussed in this paper is also the latency. I think the closest Amazon data center is in Germany or something, if I'm not wrong. And that can get quite inconvenient if our application relies on very high responsive responses from the server. And you also have the energy constraints on the mobile devices, where you have very limited amount of resources, including battery. And that can become a problem if your application is very resource intensive. And normally, if it's too resource intensive, you might start considering if some of this should run on the cloud instead of on the device. However, it's not all the time that's possible, for example, because of the latency that's between your device and where the backend instance is running, for example, somewhere in the cloud. And you also have the security and privacy concerns around this entire cloud thing. For example, everyone knows that when you're giving your data to Facebook, they have all the rights to your data, and people are kind of skeptical to what they give to Facebook and so on and so forth. And it's kind of the same thing when you are using, for example, Dropbox and all those services, where you sort of get a bit skeptical about what should be out there, since it's quite convenient to access it for others. For example, for the NSA to just get in there and just grab your data and do whatever they want with it, or any other third party, for example, man in the middle or something like that. And the paper also argues, on the other hand, that that could also be more secure to store it on the cloud compared to storing it on your device, since it's more prone to being broken. It can be easily stolen, and but when you have your data on the cloud, you normally have it password protected, and you can also encrypt it. However, you can also do the same thing on your phone. Another issue today is that you have tons of different policies and frameworks and ecosystems and all of those different things around, sort of in almost every single place in the industry. Amazon has their own policies, Microsoft has their own policies, Google has their own policies, and so on and so forth. And that can get quite expensive if you need to dive into all of that. And yes. So if anyone has read the paper, this is what they say mobile cloud computing is. However, I think it's just useless for me to just try and say this to you. So I'm going to break this down. So mobile cloud computing is basically, it's sort of an ID or an architecture rather than a new technology or something quite new. We can already see it today through web applications. And what the definition sort of tries to explain is that it's a sort of a rich mobile cloud technology where you can have very rich applications that can run basically on any device, anytime, anywhere you want it to run. And it should also leverage various cloud technologies. It should sort of unify all the different clouds into one abstract cloud that your application can take advantage of. And so you don't have to tie yourself to any specific platform, either on the cloud or on the mobile devices. So it can sort of easily switch between whatever it feels like or what is needed to according to your needs and your application. And it also discusses this payment model where you have this pay as you go, as I'm sure many of you are familiar with. You pay after those resources you are using on the cloud, instead of, for example, paying 3 months in before you actually use those resources. So I know Microsoft has, unless they change it, they have two models. It's pay as you go and pay before you actually use your resources. So it's a bit small. So I've tried to illustrate the basic concepts on the architecture about mobile cloud computing here. First, this device here. This is my phone. And that's called approximate mobile entity. And that's the local device where your application is running. And then you have approximate immobile computing entity. And that could be, for example, a data center here in Gjøvik that your application can take advantage of. And the reason that we have a split between an immobile cloud, which can be one of those very big data centers, for example, one from Amazon or Microsoft or Google or whatever, is that when you have this one here, you can get extremely low latency compared to one in Germany, for example. It could take only a few milliseconds to send a message to a data center that's down in center somewhere, instead of sending a message all the way to Germany and then wait for it to come back again. And this can, for example, open up the possibilities, for example, for cloud gaming, where you, for example, you don't have all the processing running locally on your device, and you have the graphics processing running in the cloud, which could be an approximate immobile cloud entity instead. So to summary, mobile cloud computing wants to sort of unify many of the technologies that we have today and all the fragmentation that we have in terms of platforms and devices and architectures. And there's also a lot of research that's required for us to sort of start leveraging the advantages of mobile cloud computing. For example, we need to invest more in security and do more research in terms of architecture and so on and so forth. So it's not something that we can start using right today. However, the mobile cloud computing also wants to make networking smarter, so we can more efficiently use networking technologies to avoid network congestion. So, for example, if you're going through a city, you can start using random Wi-Fi signals instead of using the public GSM or 4G LTE, whatever network. However, some of you might think, oh my God, that's like security, that's very insecure. And like I said, there's a lot of research that we need to invest into security in order to make this thing become more secure and more convenient. So it's not something that we just shoot ourselves in the head with. And in the very end, the point of this is to sort of make the life of us developers a lot simpler, so we don't have to know about all of those different things, because it can get quite a lot, which we can see today, where Amazon has their own things, and Microsoft has their own services, and then Google again has their own service, and then there's another startup thing that also comes up with their own thing that they think is the new big thing, and you have this jungle of technologies which you had to get into and figure out which one to use. And mobile cloud computing sort of wants to abstract that away from you, so things becomes far more simpler for you. And in my essay, I argue that mobile cloud computing is sort of the next logical step for mobile and cloud technologies, since it sort of tries to bind everything together again, since when there's some kind of new technologies, we sort of tend to spring out in various ways. And then something big happens that sort of tries to combine everything again. So we sort of have one single thing. For example, I discussed in my essay, I discussed how the internet emerged, where you have several different networks that in the end became one entire network, where you had various networks with different standards and thinking processes and so on and so forth. And I argue that this could be something that we could see in cloud technologies as well, since much of these technologies are pretty new, where it can happen that it sort of ties itself together again, so it becomes one platform. It might be, of course, that there will also exist as it is today, and this will sort of be a thing that runs on the side. And I think that it's reasonable that that will also happen, since, for example, on desktops or PC or Windows and Mac and Linux, there's no A4 cross-platform framework, and that could also be a hint that this could possibly take some time to get through. So I hope you enjoyed my presentation, and I would hope that you got something out of this presentation, and I would recommend you to look into this, especially pay attention to this presentation, since I found the paper extremely difficult to read. It was quite long, it was extensive, and I sort of read the definition. I can bring it back here, this thing, and I was reading this, and it was like so long, and I sort of like, brain has gone away when I was in the middle of this. And I sort of had to read it several times, and I had to look up examples online. And yeah, it was quite strange, and I found it quite vague and abstract to begin with. And then I sort of dived into examples, and I sort of started grasping what exactly this is about. I was like, oh, that's neat. Okay. So, any questions or comments or anything?
Questions?
About this cloud jungle that you said, we have a lot of like Google, Amazon, and Windows. Microsoft has something connected with this, but usually, as I know, they usually provide you just with virtual machine that
Yeah.
you can set up.
Yeah.
And you can actually unify this
Yeah.
setup. So actually, you're kind of not depend on the cloud now. I mean that the only thing that different among the services is the graphical user interface to create these machines, and maybe API that you can use to like scale, for example, dynamically. But the setup actually is quite the same. You have to just write the application of the service.
Well, that kind of depends what your application does. I know that both Microsoft and Amazon, they provide you with virtual machines, and then you can sort of put up your own stack on the virtual machines. And that sort of fits partially under the mobile cloud computing definition. But then you have all the services next to those virtual machines. For example, Amazon has their own certificate systems, IAM, and they have S3 storage and their own content delivery, networking, and all of those different things. And all of those services has their own APIs that's specific to that vendor. And if you're already just using a VM, your application will, of course, be very convenient to just switch between, for example, from Microsoft to Amazon. But if you're using one of those services, for example, S3 storage on Amazon, you want to switch to Azure Blob Storage on Microsoft, you sort of have to start making some drastic changes, maybe in your architecture, if the Microsoft architecture is quite different from Amazon. And that's sort of what this paper sort of hints about, that we sort of need to unify all of these things together. For example, I have tons of different storage, cloud storage services on my machine. I have Dropbox, OneDrive, Google Drive, and Mega, and all of those different things. And it's I have to switch between those, and that's sort of what this kind of wants to combine into one specific thing. So it can become quite more convenient. And many salespeople, they compare cloud technology as a resource, for example, as a water, so you can just open up the tap on the spring so you can get data power out of that as you want. And as it is today, it's quite different, since if you tie yourself to those APIs that I mentioned earlier, it's sort of, you need the Amazon or the Microsoft or the Google or whatever provider you're having for your cloud technologies installed in your system. And that can be quite a disadvantage. However, the paper also discusses the positive elements of having a heterogeneous system. For example, you can leverage out advantages from that system. Let's say, for example, in this class, everyone was like the same person. We had the same thinking and the same sort of mindset, all of us. And that could be a very good advantage in some courses. However, we could still do very bad at other courses, because that kind of mindset might not work in some courses. And if you have a heterogeneous system that everyone has sort of, they have their mind set up differently, we can sort of average that out, and we can sort of become more average at all of those different tasks. And the paper also discusses that it's a good idea to sort of try to leverage out the advantages of having different architectures and different systems in a computer system.
Yeah.
Yeah. So I hope that answered your question.
But usually it's, so that's actually the problem of standards to create on different services. But usually when you standardize something, you of course have some drawbacks because you have to consider what is the same on these services, and these services better at these things and this on these things. And when you start to standardize everything, you have not only like pros, you have cons as well. But I don't know if it's possible even to create, for example, one standard. I mean, it's possible, of course, but if it's achievable in the sense of that all these companies will agree on that.
Yeah. They also mentioned that in the paper that it could be a bit optimistic today to assume that this will happen right away, since they also discussed that having this kind of heterogeneous environment also provides many jobs. For example, it's more expensive for companies to implement applications on different platforms, and that creates jobs. It's a very good thing. And when you have just one platform that you can just push your application onto, you simplify the process a lot, and you don't need all of those different people on all of those different platforms. And that can be an impact of this, as the paper also discusses, that it can have a market impact that sort of people might be like, no, we can't do this. So we need to earn money and those things. And that could be an argument that the cloud vendors might use against going against this approach.
Mm.
Yeah.
Any other comments or questions for Martin? Okay, thank you very much. So we will continue discussing it, because I think you mentioned a number of very interesting topics which we can kind of follow up a little bit. So one mentioned by Nikita is that indeed, if you treat cloud only in terms of virtualization and renting VMs, then the app standards, like there is open cloud and so on, which sort of separates you from the actual providers and gives you a little bit of an abstraction layer which you can benefit from, right? So it kind of boils down to very early days of us programming computers, right? We had particular architecture that we have to write code on, and if we write a program to run on that architecture, that code was not compatible with another architecture that we would like to have the same program to run, right? So what do? We don't write code in machine languages anymore. We said, well, it's kind of it's too difficult, so let's have some high-level language, let's say C++ or C, that can compile into this architecture or that architecture, right? So we write it once, and then we can run it technically on different architectures, right? But things got complicated to a point where we have now different operating systems. So we have the computing platform itself. We have different OSs on the same platform. We have different libraries and so on. So we kind of pushed things up the chain, right? So what's the most popular language right now? What is the most popular language in the world right now? Any guesses?
I think C is still most popular.
Okay, so Java, C, JavaScript. So according to some of the stats, JavaScript is the most widely used and the most popular programming language. Why is that? Where JavaScript runs?
Because in the browser. Yeah.
In a browser, right? Way here. Like, it's a browser. I mean, you don't even know. You don't talk about CPU anymore. You are so much high in the stack of virtualizations that, you don't care what libraries they run, what operating systems they run, whatever. You just know they have a browser, right? And that's your target platform. Your target platform is a browser, right? And that means you can run virtually on anything which has a browser. Is it a mobile phone? Yeah, it has a browser. I can run my code there, whatever. So we kind of went up the chain to kind of the highest point currently is this sort of point which unifies all this which lies beneath. But as Martin was saying, it has advantages and disadvantages sometimes, right? So you have to consider what you benefit from by targeting that high-level kind of point, or what you benefit by targeting somewhere else, right? So Java is popular, and C++ is popular, but those three have different strengths and different weaknesses, right? So you could say .NET similar to Java, right? So if you're writing a game and you need to be low to the hardware, you need to benefit from the GPU and so on, you're not gonna write it in JavaScript, although there are projects which try to help you to do that, to kind of expose some of the native capabilities to the browser so you can actually write a high performance graphical applications on that level, right? So they try to separate you from the actual hardware, but expose enough that you can benefit from the hardware beneath. But typically, you would sort of do this. You would sort of, write a native application which talks to the hardware directly and then benefit from that. But there are obstacles. So if you did that for Android, as Martin was saying, and now you have to rewrite your game for iOS, even though majority of your code is in C or C++, you still have some things that you have to glue to the native platform. So it may be not a complete rewrite of your game or your app, but you still need to maintain it, and you still need to provide enough support that it kind of works. And if you have to do it for Android, if you have to do it for iOS and for Windows Mobile and for something else and for something else, it becomes kind of a burden, right? So that's why we see this tendency for saying, well, how about we just do it in JavaScript? We have some sort of virtualization mechanism which exposes the native kind of hardware capabilities to us, and then we can support a number of platforms. Right. It's a good thing. Is it a good thing to be able to write code once and run it on multiple platforms with the hardware capabilities?
It depends.
Exactly. So what it depends on?
Well, it depends on your needs. If your application can run on a high-level language, that's completely fine.
Yeah.
But if you're, as you said, if you are writing a game that's very resource intensive, and you might require to use some native APIs, for example, Qt or something like that,
exactly.
It would be more reasonable to go with, for example, a low-level language like C or C++.
That's right. So it depends, first of all, on the purpose of why that app is being created and what the purpose of that app is, right? Also, it depends who the stakeholders are. So the world looks really different to, app developers, mobile app developers, than it looks for the mobile platform developers, right? The world looked at from the Google's perspective looks really different. I, as a Google, having my Android baby, I like all good developers program on Android. I don't want them to program on iOS because it's a competing platform. I want them to do it for Android, right? Apple has the same perspective. They want developers to be on their side. They want to log them in, right? So what they do, they have different languages. So if I'm a Swift or Objective-C programmer, I'm very unlikely to be also a skilled C++ and Java developer because, I'm kind of locked in on one side of the spectrum. So they kind of create artificial barriers, right? Interestingly, when Google came up with Android, they actually picked the language which appealed to the majority of the programmers. They didn't pick some esoteric, novel language which nobody knew about. They said, which is the language which the majority of programmers know and can program on this new platform? And they picked Java, right? They were considering using native, but they said at that time that it's kind of hard, and majority of people don't actually program in C and C++. It's more specialist sort of language. Majority of programmers were at that time programming in Java, and they said, okay, let's do that. Let's try to appeal to them. And of course, you have native interfaces, and you can program in C and C++ as well. So they kind of opened up, right? Apple is not doing that. Apple is not saying, well, okay, we love Java developers as well. Let's let them program on Apple, right? They kind of said to the contrary, we kind of block Java. You cannot run Java on iOS devices, or they don't like Adobe Flash and so on. So they don't like any competing technologies. They just want the kind of lock-in. So, that's a big problem. And as great the vision is for unifying things and standardizing things,
market forces kind of play against it, right? So you really clearly see that comparing the early days of internet and what's happening currently, for example. So in the early days of internet, nobody was really making a lot of money on the internet. It was sort of it was more like a movement, right? It wasn't very commercially appealing to do anything on the internet because there were not big money involved. And the money which were involved were usually government grants and university grants and research projects. And what those people are, they kind of say, yeah, let's work together, right? So they created standards. And those standards made internet possible, right? Because nobody really needed to lock anything to kind of shield themselves from the rest. The main point was to kind of open up and collaborate instead of locking in. So for example, we have email, right? Email is possible because there is a standard protocol for sending and accepting emails, and any company can write email client and any company can make email servers. But who is making money on email clients and email servers? Nobody really, right? It's not a good market to be in, right? You have open source email clients and email servers, and that's it. I mean, if you said, hey, I have a great idea for a new email client and email server, and you pitch that idea to venture capitalists, I mean, they say, how are we going to make money on that technology? I mean, it's commodity, right? So by standardizing things, you commoditize those things. You make them sort of, not extremely valuable, right? So you have to find a value proposition which works on top of those standards, and that's hard. So typically, it's much easier to create value by creating those barriers, and you said that, right? So the barriers create jobs, and they create opportunities, and they create value, and that's what you can monetize on. If you remove the barriers, suddenly it's much harder to create value, to generate jobs and to create profits. So there are kind of two, in very abstract, you can think of it as two strategies. One strategy is that you have some sort of a skill, or you have some value generation that requires some work and produces the value, right? So let's say you are a blacksmith, right? Or I don't know, blacksmith might not be a good idea. You are a coder, right? So you can create code, and that creates value, right? So you can do, someone says, I need this piece of code. You go there, you do that. They pay you, right? And the other guy says, I need this to be written. You go there, you do it, and you get paid, right? So it works, right? You do the work, so the work generates profits, right? You do the work, you generate profit, right? But there is a bit of a problem with this, right? The problem is this. We don't like to do work, right? So this is one model which works, and of course, it's kind of a pretty generic. The other one is based on rents, right? So here you can do something. Here you have something, right? So let's say you're a landlord, you have a house. You can rent it, right? It doesn't require you a work as much as building the house. You already have it, and you can, because you own it, you can rent it and get value out of it, right? So doing rents kind of magnifies your profits because you do a little bit of work and it gets magnified by the ownership of what you have, right? So how it works in software? Can we turn the developer into a landlord? Well, we do, right? We become game studios. So we write a game and we sell it to millions of people, right? We own the game, and then we sort of are landlording the game. instead of selling the work that we do on per case basis, right? So we try to instead of doing services, we try to do products, and then we own the product and then we resell it. And then reselling the product is much cheaper than redoing it over and over again, right? So if we have something, we have some sort of capability or some sort of product or some sort of thing that we own, we can magnify the benefits. And that's what happens with the platforms. So Apple is not the richest company in the world because they continually doing great things. It's because they own something they can resell and sort of monetize on, right? So they created the platform for App Store, and developers can develop apps and sell it, and they kind of are owners of it, right? So they are a landlord of the App Store, and they charge 30% for being able to distribute your apps and advertise it to the customers, right? So once they created it, the amount of work they have to do is very little. They don't actually need to do a lot of work anymore. It sort of runs on its own, right? So there is a tendency to sort of start somewhere here, but to push it as much to the landlord model as possible because it sort of magnifies the profits. But that creates, as Martin was saying, creates a kind of problems. Like you have Mega, Dropbox, Google Drive, all those facilities, and you have to keep switching between them. They have different clients, they have different ways of interacting with them, and so on and so forth. Why? Because they try to become landlords of what they have, right? If they commoditize it and they say, well, okay, let's make all storage equal, it's always the same API, it's a cloud storage, how different it is, right? You just upload a file and download the file, right? It can be encrypted or not. And there is not as much variety. You cannot really diversify the experience or the service that much. You could just unify it. But if you unify it, what would happen? Well, it would be commoditized, right? It would become sort of, you don't care with whom you're working because it's just a storage, right? It's like, with hard drives, how much attention you pay to which manufacturer hard drive you have on your laptop. I bet you don't even know often, right? You just got a laptop and it has a storage and you just don't care, right? For those manufacturers, it matters a lot, right? Those manufacturers' life depends on selling their product, not being kind of a commodity that people don't care about, right? So the storage providers, they really want to care, you to care which one you use. And I mean, honestly, you don't care, right? I mean, that's why you have all of them, right? And all of them offer some free space, and you just use all of them. And you kind of, as a person, you honestly don't care whether it's a Dropbox or Google Drive. I mean, maybe the experience is a little bit sometimes easier. Some apps are a little bit easier to use. Like Mega didn't have the kind of a client. You have to do everything by web, and it was a bit painful. But now they have a client as well, so it's kind of like everybody else. It's sort of the same experience. But if you tell them, hey, let's guys, come on, just be grown-ups, just unify it, make a single interface and make it consistent for developers, and it will be so much easier for everybody. They would say, yeah, for everybody but us, right? For them, it wouldn't be that great. So there is a tension, and as great the vision is, I think it takes time to kind of to do that, right? But it may happen. It may happen because certain things become commoditized by their very nature, by the market forces, and then you have to just standardize it, right? So in programming languages, we've seen that as well. We had,
A good example of this standardization can be graphical libraries like OpenGL and DirectX.
Exactly.
Yeah,
Exactly.
They came up with Vulkan. You think that completely like one standard for everybody,
Yeah.
cross-platform and everything. So they just, it seems they just tried to create like different standards for each of them and then support everything.
Yeah.
And they just came up with something one can easily used by everybody.
Yeah, that's right. So there is a kind of So the graphics is a good example, and JavaScript is another one. So let's start with the graphics. I wanted to start with JavaScript, but because you mentioned it, so let's start with graphics. So what happened was you had competing standards. So of course, Microsoft was pushing their own kind of, you want the game developers to do it for your platform, right? So Microsoft was kind of really hot on DirectX, and they wanted kind of developers to use that technology, and then everybody else was either using OpenGL or some other technologies, right? But they didn't want to give up, so they standardized it, but it was kind of still locking people into a particular standard or particular platform, right? And then what happened was mobile came about, and mobile GPUs became kind of a hot topic, because if you had a mobile phone which could do smart graphics cheaply, you would buy that, right? So the handset manufacturers were really keen on having GPUs in their mobile phones, but the normal GPUs were kind of designed for PCs, and they had those kind of competing standards. But for the mobile headset manufacturers, you just don't care. You just want as much innovation and as much progress to be done for the mobile GPUs as possible, so you bring it up to a point that it consumes low power and they can do a lot of good things, right? And it just happened that the most open standard was OpenGL. And OpenGL, like 5 or 6 years ago, wasn't as hot as it is now. It was kind of struggling. It was actually losing to DirectX. But because of the mobile push, there was so much innovation happening, and so many companies kind of trying to put money into it and bring it up to a certain level that, if you were to choose DirectX or OpenGL now, you would lose if you choose DirectX, because OpenGL is so much better now. It has much more support, much more capabilities, and it's much more widely supported. So the standardization kind of happened because the stakeholders changed. It wasn't the kind of game platform owners who were kind of directing the game. It was the hardware manufacturers who wanted the best experience for the end consumers, and there was no gatekeepers at that time, right? And that created this sort of transition. But you need certain kind of things to kind of align for this to happen. And when it happens, it's great, because the standardization of OpenGL, the standards are coming very quickly now. The working committee is very active, and they have a lot of innovation and a lot of kind of good things happening. And Vulkan is kind of the next, next step in this kind of fast-moving world. But it's still without. It's still not without certain, problems. So let's say, let's talk about Apple. So Apple produces their own GPUs, right? So you have the OpenGL, you have OpenGL standards and the kind of the ES versions for the embedded systems and mobile devices, and it's kind of standardized. So everybody is a level playing field, right? So if you write a game, it will you will use the features, and it will it will run on iOS devices, and it will run on Android devices the same, because those are the same it's the same standard. But Apple said, because Apple is producing chips themselves, they can produce a chip which has certain novel capabilities. So they kind of innovating, they kind of adding new features in, right? And those new features in are not covered by the standard yet, because by their very nature they are new, right? They are modern and sort of cutting edge, and there is some innovation happening. So what Apple did, they say, well, actually, we will kind of put a special thing on top of OpenGL, yes, which we call Metal, and it will be only working on our chips, right? So if you're an Apple developer and you want to use the latest and greatest features that they have in their GPUs, you have to use their API, right? Which is not compatible with OpenGL anymore. It locks you in to their GPUs, right? Clever trick. But if this innovation is good, some manufacturers will pick it up, and the standard will pick it up, and at some point, it will not be beneficial anymore, right? So you may have, you know, I don't know, 6 to 18 months kind of a head start with some of the features which are really good. And then it will kind of level the field again, because those features will be adopted by other manufacturers, and it will end up with the standard, because the standard is kind of quickly following up with the with what's happening on the market. So efficiency here, how quickly that happens, makes either this a viable option or not, right? If this is too short, then you just don't bother, right? Because it's a cost. There is a cost for you to not use standards as a developer and to benefit with some of the features which may be just here for 3 months, because everybody else will have them in 3 months' time, right? But if that takes, you know, 2 years, then, well, you know, in 2 years you can sell a lot of games which have something nobody else has, right? So how efficiently that innovation and integration happens dictates how, you know, how it works. And who benefits from it. Like, obviously, with the manufacturing of your own GPUs and owning the API and owning the platform and trying to gatekeep it from the, you know, competing platforms, Apple benefits from the, you know, building those barriers. But the developers try to, you know, to mitigate those barriers, and also, you know, competing hardware manufacturers also want to be as quick adopting the new innovative solutions as possible. So, you know, you may have certain things that sort of drive the innovation, and what drives the innovation is trying to create a barrier. But then, you know, the majority of the innovation kind of happens because of the collaborations. So there is fundamentally, philosophically, you have kind of two competing concepts here. So one says, you know, creating the barriers and isolating it creates value. It creates the innovation, and that's why we have patent system, right? Because you can say nobody can use it for whatever 20 years or something, right? But the opposite says, well, actually, you know, why not, right? If you came up with something and I came up with the same thing independent of you, I didn't steal your idea, I just came up with it, right? And why did I came up with the same thing as you? Because there is a kind of a common ground. We have a common understanding and common level of expertise. Then we can both kind of come up with similar things, and we push that forward. And now more people can come up with new things, right? And that's what drives the innovation. It's not locking you, which drives the innovation. It's kind of pushing the front of our knowledge forward by whatever means we can. And the more people come up with certain things, the better, right? So in physics or in mathematics, you cannot say, you know, I came up with this formula, nobody else can use it, right? I mean, that's great. I mean, you take some credit, you get your name on a formula or on some equation, but often what happens is in physics and mathematics, there are, you know, multiple people coming up with the same thing at the same time or shortly after, right? Because there is no patent system, right? There is no locking in, and that's what drives the innovation. So you have sort of a kind of two philosophically competing ideas about innovation. One is, yeah, the barriers are good. They kind of drive some value generation. They create some profits, jobs, and they drive innovation. The other one says, no, actually, it sort of looks like they do, but they hinder the process. They hinder the pushing the front forward. And if you consider the graphics, the world before mobile was not as innovative as the world when OpenGL kind of took over and unified everything and leveled the field. So there was less innovation happening in OpenGL and in DirectX in the last like 20 years compared to last 5, when people basically started only doing OpenGL and pushed the standards forward so much. So that's one thing. The other thing, yeah, is JavaScript. Like, we've seen it with Java. So when Sun Microsystem came up with Java language, what did Microsoft do? They came up with J++, right? They say, actually, we have a very special Java for only Windows systems, and it has certain features which are specific for Windows, and we would like, you know, our developers to use this language instead of the sort of standard language, right? because of the lock-in, right? So if you were J++ developer, your code wouldn't run on normal Java. So, but because you were targeting Windows devices, then that's fine, right? So that is kind of an interesting case where even standardization of the language was causing some people or some companies trying to build barriers, right? Microsoft lost the lawsuit. So some said actually because of the specification on the language specification and the VM specification, you cannot do that. You cannot add extensions which are incompatible with the standard. So the kind of a J++ got killed after a few years, and Microsoft kind of dropped it and pushed the .NET platform, right? So they originally invested into kind of because the concept is cool, right? The concept of virtualizing something above the operating systems and being kind of independent of the operating system layer is good, and it's also not just about the language. It's kind of more about the JVM, really, right? So it's about the virtual layer on top of which you can program in different languages, right? So this is a kind of an innovation which happened, which sort of got standardized, but Microsoft's route was not to jump on board of some sort of technology, was to try to, create some sort of thing that they can rent, and they sort of, after that got killed, yeah, they went into .NET. So they redone the work that's been already done. And to be honest, they did it better, right? So the .NET on the VM level is more advanced and more innovative than JVM, right? They have like Taylor recursion, and they can support functional programming much better on VM from Microsoft than on the JVM. So technologically, they kind of did a slightly better job. But it doesn't mean that job couldn't be done there, right? Maybe it could have, right? And then you can program in different languages on top of the .NET. And same, you can program different languages on top of JVM. So you have Scala, you have Clojure, you have other languages which are very popular now on top of JVM, which happened there. So with JavaScript, it was kind of similar, right? Originally, each browser had their own JavaScript engine, right? And you had those weird web pages with those if statements saying, okay, if this code runs on Microsoft Internet Explorer, you need to do this. If it runs on Mozilla, you have to do this. If it's in Chrome, you have to do this. It's like, it was kind of a mess, right? So it was a mess to a point where developers said, we just screw it, right? Some browsers we will just not support anymore, right? We will write apps which don't run on central browsers because it's such a pain in the ass to support all this diversity, right? And then the browser owners saw that some apps don't run on those browsers, and what that happens, what that leads to is people stop using them, right? If I cannot go to a web page using that browser, I stop using that browser, right? So Microsoft said, and Mozilla and so on, they said, shit, that's kind of bad for business that, we cannot be used for certain websites, right? So, again, there was a push for standardization. There was a push that the browsers owners decided, okay, actually, it's in our best interest that our browser can be used on all the websites. And, developers don't have to go through those stupid web if statements, right? It just doesn't make sense. So after the initial sort of creating barriers stage, they decided, okay, let's kind of unify it, right? So they rewrote some of the engines and they open source some of the engines, and like the Google JavaScript kind of core engine is now used in other browsers as well, right? It's a technology which Google could lock in people, but instead they say we benefit more if everybody uses it, and then it's more unified because we really make money on other things than locking people in particular JavaScript technology, right? So JavaScript went through a bit of a turbulent past, but now it gets standardized, and now there is a kind of an ongoing process, same as with OpenGL and same with C++, that there is a committee which decides what is the standard, and then the browsers just support it, right? And it's not really in browsers' interest to support features which are not in the standard, because just developers will not use it, right? Developers will code against the standard because that's the common denominator. It kind of covers the market. So, all right, so we have a standard, and we have, ECMAScript 5 being supported by majority of browsers right now, and there is in 2015 was ECMAScript 6 kind of standardized, right? So we have this being the official standard. Unfortunately, it's not yet supported by all the browsers. So some browsers support it to some degree or not, right? But the developers know, okay, that's the language, right? So you need some sort of again, virtualization layer where developers can code against this, and through this it gets translated to the current sort of standard that the browsers fill in. If they support something, it runs natively. If it's not, it has to be translated to that, right? So we have some polyfills which kind of do the translations for us. But the question mark is, what about ES7, right? How do we do the innovation now, right? What is it? Is a committee deciding what the new features are? It will not work, right? If a bunch of standardization bodies decide, okay, what are the new features of the language, they have a very limited innovativeness, right? Even if they are very smart people, and even if it's a lot of them, they still are very limited. You need to open it up, right? You need to make sure that everybody can contribute to this innovation process and make sure that good things happen, right? So how you do this? Well, by very nature, you have to have some forks. You have to have some new languages. You have to have some incompatibilities. You have to have some companies saying, oh yeah, that's gonna be the best new thing, right? And again, you've seen that Microsoft had, so they have a TypeScript, which they try to innovate what the next, versions of JavaScript will have. Google had EdgeScript, which is another language which they kind of had their own features in, and so on. So Apple is kind of outside of that game. But Microsoft and Google and I don't know what the what other kind of research centers were kind of doing in terms of languages, but they trying to kind of do this, right? And recently, Google and Microsoft kind of unified those two, and they say actually they complement each other. They were, this one had annotations and had a lot of kind of extra metadata attached to the language, to the core concepts, and that one had kind of a strong typing. And they said, Google and Microsoft said, it kind of only makes sense to unify it, so they merged those two together, and that might feed in to what the next features are of the official language. But they kind of started to collaborate, and that creates the value. It creates kind of new things, which then feeds back to the community, feeds back to the developers, and it kind of drives the innovation, right? So it is, this kind of virtualization stacking and offering things which kind of flatten the playing field. From one hand are always good, but from the other are kind of cumbersome and difficult sometimes for the owners, right? For the ones who kind of own the networks and so on, right? So we've seen that with telcos. So when the internet started happening and people started using VoIP and so on, the big telcos said, oh, okay, how can we jump on board? How can we do what Google is doing, or Facebook? How can we offer services to our millions of subscribers that we benefit from? But they were really into the kind of a rent business, right? So they own the lines, they own the customer base, they own everything. And the idea was to create kind of a walled garden ecosystems where developers can submit apps, which those apps run only on the kind of network, right? Because if you have Telenor or Chess, they don't want customers to be able to use the same apps on both platforms. They want to have kind of a differentiating factor. They want to have apps which the competing platform doesn't have, right? But of course, if you're an app developer, I mean, you don't care about their politics and you don't care about their business models, you care about yours, and your one is the more platform you can support, the better. right? So if you are a developer back in a day and you wanted to work with the telco operators, it was a nightmare. It was much worse nightmare than supporting iOS and Android and Windows Mobile, right? You have to cut deals individually with each of the operator in the country, and if the country has 10 operators, you have to negotiate with all 10. You have to cut deals, sign agreements, and code against the API for each of the platforms, right? So it never worked. So the original idea for offering smart services and smart apps and smart things on smartphones and so on with the telcos never caught on, because they were really locked in this kind of single-minded rental model that they own it, so they can benefit from it, from kind of renting the APIs they have, or renting the capacity, network capacity that they have, and so on. And this kind of more open, more service and skilled and can do, model of the internet kind of took over, and that's why you see all those sort of services being offered on the internet, but not by the telcos. And the telcos got sort of commoditized, right? It got pushed to the IP layer, and then if you an app developer and your traffic goes over an IP, you don't really care who is the provider, right? Who is the operator? It got commoditized. Right. So that's one thing. The other thing Martin mentioned is the payment models, and that's also very important. So that also changed. There are multiple factors for this, but one is kind of the growth of electronic payment systems and the kind of ease of doing micropayments, right? So you wouldn't say it's reasonable to assume I have to pay upfront, $10,000s of dollars for a capacity that I will be using for building my app, right? You just launch the app. If your app uses little resources, you pay almost nothing, or you are in the free tier. And then if your app grows, you start paying more, and that's what you expect currently. But it wasn't like that, a few years back. A few years back, you have to provision your needs. You have to say, I need that capacity, and I'm paying upfront for that capacity, right? So changing the payment models kind of changed what is possible now, because you can try things out. You can be more innovative, because you don't need to offer a service to millions of customers. You can offer it to small number, but you can easily grow, right? And that's what kind of brings us back to the discussion about the cloud services. So one thing is that Nikita was saying is, if you kind of have VMs and somebody provides a service which offers those VMs, then this kind of is already commoditized, right? But Google or Amazon or Microsoft, they don't only do that. They do that as part of their business, but they offer platforms as well. So they say, we actually do more. We offer you a container. You can run your apps here, and we will spawn the VMs for you as needed per demand, right? So they offer platform as a service. And then there is one layer above VMs. Why? Why would you use that instead of managing the VMs yourself? Well, because it's more work, right? And you need to know how many you need to provision it, you have to handle the spikes in usage. If you are, a game studio which uses some sort of a backend, and there is Christmas and suddenly millions of people use your game, you have to provision more, and you have to do it up front, right? Because you have to spawn the VM before you can use it, right? With the platform as a service, you basically say, well, I will be paying as I go, and if there is more demand, we scale it automatically, right? Otherwise, you have to take care of it. So there is more work. You can do it on this level, but there is more work. And then you're a little bit more independent. If you do it here, there is less work, but you locked in more, right? So we see this thing here. We kind of, in the innovative space, where people offer you things which other people don't necessarily, but they do it in a way that is kind of unique, and you locked in, right? So there are certain things Google App Engine offers that nobody else offers, and you have to log in yourself to Google App Engine. Martin was mentioning S3 for storage is kind of the same, right? So they have certain features and certain APIs and certain things which kind of lock you into that particular model. But we kind of there. And this, as we were saying, got commoditized. That was quite new as well, but it became sort of commoditized over the years. So now, renting and spawning a VM, you can use Vagrant and whatever you use, and you don't care they don't care which platform you're using. You can do it on Amazon, you can do it on Google, whatever. You will just get a VM with certain pre-configured system setup, right? So that got standardized to the point where, you're kind of independent of the vendor now, but that not yet. It may happen, right? So the question here is, what are those things which we need as developers, which either got standardized already or are kind of not standardized yet, and how we decide what we do. Do we roll our own solutions, or are we locking in ourselves at least for a while with a particular vendor? So Martin mentioned storage. Storage is one, and VMs. Well, you can say VMs or computation, right? So that's another one. So we have two. What else? What else is that cloud offers us in this kind of similar fashion?
Processing.
Yeah, processing. Processing, like kind of clusters or GPUs or what have you, right? So kind of more heavy-duty processing. You can even have a subcategory which is particular algorithms, right? So Google, for example, has services which have machine learning algorithms for rent, right? You can run a particular clustering algorithm or whatever you need to run in a cloud, right? It's sort of it's algorithm as a service, so to speak, right? So it's that. What else? What else can we use cloud for?
Well, for the scaling thing, when you need to scale and spawn virtual machines.
Yeah, yeah. So we can say, yeah, how would we call it? Yeah, scalability. What else?
Networking.
Yeah. So networking in general. And part of the networking is messaging, right? So both in terms of push-pull and in terms of actually like messaging protocols, right? So you can do you can do push notifications or remote installs or the kind of clever things that we do between web browsers and mobiles, right? Because of the cloud infrastructure that Google or Apple offers. That would be really, really difficult to duplicate or replicate yourself, right? You definitely need to go with the vendor or with the particular lock-in to get that facilities currently, right? We were discussing it a little bit last time, that it would be nice if it's kind of unified and standardized, but it's not yet. And that's definitely not replicable. Scalability, it's not replicable either. I mean, managing your hardware systems and so on, that's really hard, right? This you can do if you are big, so big companies can kind of do this, but that's hard as well. Storage, so storage has a couple of elements to itself. So just raw storage itself is not that difficult. I mean, you can buy a couple of terabytes drives and you can store a lot of stuff at home, right? You can put a small cheap solution based on Raspberry Pi, for example, or whatever, and you can have your kind of a storage solution where you put almost, yeah, we have a researcher who was working on indexing documents and indexing web pages and so on. And he said, the indices of the entire web are actually not that unmanageable. You can sort of, store an index of Google-like service at home, right? It's not, the index is not as huge as you may think. So it's not unbelievably, huge. So storage-wise itself is not a big deal, but you have the ability to read from that storage, the ability to, if you're storing a couple of terabytes of data and you have millions of users using that data, suddenly it's a problem. It's kind of a scalability issue, right? You cannot do that at home, right? You can process it at home, maybe, but that's not that easy. And also, you have replication issues here as well. So, making that storage safe, making that storage fail-proof. So if one of the hard drives dies, what happens then, right? So you have some redundancy and so on. And then as this grows, it becomes sort of cumbersome. So even if you imagine, okay, I can have RAID partitions and so on, but then you have to have solution which, like, let's say you build your small data center, you put all the hard drives in, you have a proper backups and you have a proper replication of data. What happens if your data center burns down, right? Well, you have to have something which is located somewhere else that basically replicates the data, and then it becomes kind of cumbersome. So cloud providers offer that for you, so you kind of are resistant to earthquakes or fire and so on, because they spread data all over the world. They have multiple sites where they store the data and so on. So that, I would say, that is kind of harder to do yourself now as well. And then VMs and kind of a computer, of course, it's much easier with the cloud, right, than dealing with the physical hardware yourself. So those things, some of them are sort of really locking you in. Some of them, you kind of have a choice already. And the space is kind of changing. So the vision that Martin was talking about is sort of slowly happening, and definitely not going to happen soon, but that's the direction. That's what is sort of unfolding, right? Because of the interplay between market forces and the innovation and the developers. Because at the end of the day, I mean, the end users pay for the services and for the apps and so on. And if you, and for the end user, sometimes certain things get commoditized earlier, right? So for a lot of people, they don't care if it's an Apple or Google device, as long as they can play their favorite game, right, on it. So as long as it does the things that it needs to be done, the rest becomes kind of commoditized. And as much as Apple pays for the marketing and so on, at the end of the day, if the phone does exactly the same as the other phone, they become commodity. So the value is in the apps, and the value is in the content, and the value is in the interactions the users have. So yeah, so it is kind of a complicated topic. It touches on a number of issues. So the cloud itself, the integration between the cloud and mobile services, the paying mechanisms, they democratized a lot of things, the ownership, and the kind of interplay between innovativeness and those kind of rent-like models for doing business. And it is an interesting space. It is kind of an interesting space that unfolds because of the speed that innovation happens. So you have so many things happening so quickly that you just need to keep going and keep updating yourself. So you've seen it with Nokia a little bit, that they sort of lost, right? So Nokia was one of those kind of companies which were more on the rents. They had a very dominant position in the market. They basically were the leading headset manufacturer back in the day. and that creates a certain inertia, right? So you know where the core business is, and you know where your core profits are coming from, and that hinders your sort of ability to move faster. So, yeah. Any other comments or suggestions or thoughts? So one interesting experience I had was like 2 years ago. We started using a web framework called Express on Node, and it was a revelation. It was so much easier to do web services and sort of RESTful APIs with that framework than with anything else before. And I've used Java and so on before, and those were kind of a heavy duty, a lot of code, boilerplate code and so on frameworks. Whereas with this one, it's so much easier, right? And you feel that was a huge improvement. And recently I started using a new framework, which is built on top of Express, which is called Loopback. And that's like almost the same jump, right? So I thought Express was brilliant, but now I think Express is very low level and it's very kind of tedious to work with, because you have new framework, which makes it even better, right? And it's just like, 1 year difference. And people kind of came up with models and with ideas of how you can even improve that, right? And it is happening really fast. So, and it is kind of important to keep up, because I was reading an article and the person was comparing, they've implemented a system like 2 years ago. And they said by re-implementing it from scratch in this new framework, they've used 75% less code, and it took them about 75% less time to do it, right? And that's huge savings. So in terms of project development time and costs, if you can cut your cost by half, I mean, that's incredible. It almost never happens, but technology enables that, and the technology can make you much more productive and much more efficient. So you have to sort of, sometimes it's not as important, but sometimes it's really important. And with the cloud and with some of the solutions that you have under your fingertips, it's incredible. So, in the past, if you were to develop a simple, like a shopping cart e-commerce site, it would be like a multi-year project, right? That's how it used to be. Now you can prototype something like in a few days with a colleague and have it run, actually being live. It's not a mock-up, it's actually a live site because of all the tools that we have. So you have a lot of libraries, you kind of abstracted away a lot of complexity, and it became sort of trivial. It's just like using API. But you see the same with programming. I don't know, like with your programming courses, but when I started studying programming, we had to implement all the algorithms ourselves and do like sorting ourselves and everything like this, right? Now nobody does that, because there are libraries for doing all of those things. You just need to make a single call and suddenly it's done. With mobile programming, it was the same. So when we started teaching mobile programming like 6 years ago, to do, if you think about a web service from where you're gonna get a JSON object and parse it and have it kind of represented in your app, that was like probably like a couple of hundreds of lines of code to do that. Now it's almost always like few lines, like one line to make the call, and then a couple of lines to handle exceptional circumstances, and a couple of lines to handle once you get it back, right? It just got abstracted away so nicely that it's trivial. Before it wasn't. I was visiting Aalto University in Helsinki, and I think they had a couple of PhD students and master students working on a mapping system for navigation. So you could have a Nokia phone back in the day, which displays a map and displays of where you are, and you can kind of use the gyroscope to kind of orient the map. And they also work a little bit on the 3D buildings. So you can tilt the map and you see the buildings in 3D, right? They spent, as I'm saying, they had maybe like 7 people working on it for about 4 or 5 years, full time, right? Now, if I tell you, okay, can you make me an app which has a map and tells me where I am and navigate, or has that kind of a 3D view? I mean, come on, it's like a couple of lines using Google Maps, right? You can do it in 2 days yourself with no, PhDs or master's degrees. So certain things become so dramatically simpler, then it's just unbelievable. Programming Nokias in the C++ was a nightmare. I mean, I don't know what was the most nightmarish programming experience you had, but programming native Windows, Win32 apps was not nice. Programming on Symbian with C++ was not nice. It kind of almost is like programming in assembly. So it's C++, but it really feels like it's a very, very low level, very, very low level APIs. And then programming X system on Unix also is a nightmare. So those are kind of back in a day sort of ways of doing things which completely got wiped. So what was the hardest kind of programming experience you had? The most low-level thing that you had to code?
I had to deal with some sockets in Win32 apps.
Yeah.
So I had a .NET application that was relying on network connectivity and was very network intensive.
Yeah.
And I realized that the .NET wrapper around the WinSock API was causing a lot of overhead. So I wanted to directly talk to that by not using the .NET wrapper. So I had to implement everything in something called C++ CLI, which is Microsoft C++ version for .NET.
Yeah.
And you can quite conveniently talk to
native code
through there. Yeah. And it was okay once I understood it, but it's like understanding that part of them. And they had like C APIs in an object-oriented languages, and that sort of like didn't fit well together. I mean, I had to sort of
work it out.
Handles, and I got obscure error messages all the time, and suddenly my application would just stop and just not do anything.
Yeah, exactly.
That was just weird.
Yeah, that's exactly the experiences that we almost never have anymore, right? Mm-hmm. So that is kind of abstracted away to much more convenient language mappings and much more meaningful error messages and so on. Before it was sort of those opaque handlers being passed around, and you like a lot of magic happening on the pointers, and so that's this. But I mean, as you're saying, I mean, once you understood the logic and once you understood how it was working, at that time it was okay, right? It's just that a modern programmer expects more. You don't expect to be programming in that, low world anymore. You kind of like the high-level concepts. You like nice API shortcuts, syntactic sugar, things that are kind of easy and convenient. So it does, it happens on multiple levels, almost everywhere, and in mobile in particular. So that is changing really rapidly. All right, so we spent some time discussing the mobile cloud and the integration and interplay between the mobile worlds and the cloud. We talked a little bit about the graphics. Unfortunately, we don't have a topic on the mobile GPUs, which I spent some time talking about it, but it's sort of an interesting use case for what can happen if, companies put their minds together and push something forward. And OpenGL standard is one of the good examples of that. So they have some conferences and there's some talks. Maybe I will dig something out and put on Fronter, because it's kind of really, opening eyes if you see what actually happened with OpenGL over the last few years, that it sort of bootstrapped itself afresh, and it was like a few years back it was almost dying technology because DirectX was sort of the more dominant one. And we talked a little bit about the cloud services and the levels at which we can talk about it, and a little bit about the payments. So I think there is another topic on monetizations and payments models, so we can discuss it more. So that's it for today. You have any questions or suggestions? Next week, I will talk with Simon because I'm away, and I will see if he can come and have a discussion with you. So I will email everybody through Fronter once I check with Simon. And double check that you have the papers and the counter and reviews properly placed in the matrix.
Can we have some explanation how to write reviews and other arguments? Like just read
Yeah,
it.
so the review, in the review, you're sort of focusing on the essay, right? So you, as I was discussing early on, so you kind of judging the essay based on the presentation, based on the merits, and based on the argumentation, and you're sort of saying what the essay did wrong or what the essay did well, and you're providing some evidence for that. So if you, for example, have some concerns about the language, you say, oh yeah, there are some typos, and you put, you list them, you kind of demonstrate the evidence that there are typos or some grammar mistakes, you kind of list that as well. So you try to back up your claims. So you try to back up what you're saying about the essay by pointing out to the things that you can bring up. And then you kind of judge the argument. So you don't need to agree or disagree with the author. You just have to judge the argumentation based on logic. So does the conclusion follow up from the premises, and does the arguments are kind of consistent with what the essay say, right? So you don't need to say anything about the actual thesis of the essay. You just say, it was good because it argued for this particular thing based on those things, and that was logical. Or you say, no, it was a little bit difficult to agree or disagree with the author because it wasn't clear or whatever, and you say why, right? For the counter arguments, you're basically writing an essay specifying arguments against the arguments that were specified in the essay. So if the essay, for example, says, oh yeah, this kind of move will happen, like the unification of some of the services and standardization is definitely happening, you can say no, because of the market forces, that companies will always try to gatekeep their own technology and so on, and you can bring up some evidence for that.
But should we find another paper that maybe suggest something different?
You can use another paper.
If
if we
agree with the topic?
Exactly. So like if you disagree, it's easy because you just bring evidence for disagreeing. If you agree, it's a little bit harder because you have to say why you agree, and you have to sort of bring, like by just repeating the arguments the person said in the essay is kind of not enough, because you have to say why those arguments are actually correct, right? So, but you can do that. You can counter by agreeing with the thesis as well and bringing other new evidence for this, or sort of listing the evidence that the person listed and sort of arguing for that, right? So you can.
We can find the papers that agree.
That's right. You can bring them in as well. And by papers, I mean, if you just bring one, that's fine, right? You don't need to have a lot. So don't do like a full-blown research on it. Just try to argue for it. So the main point here is more about your ability to express arguments than the depth of the knowledge that you're gonna get, right? I mean, it's great if you can read more than one paper, but that's the bar. I'm not saying you should read a lot of papers. So if you can bring one extra evidence for that, that's great. It's just the way you kind of express it.
For example, arguing this kind of thing, we can just say that companies benefit from having this low technology, and we do not have to support our claim with papers or something. We can just say.
Yeah, that's right. So if you can support it by something, as evidenced by Apple inventing the metal, for example, that's good. But if you skip it, that's okay as well, as long as you kind of list those evidences. Yeah. So in general, you should always try to back yourself up with something, with some example of what you're saying is true, right?
But for example, I can say, for example, Apple with metal, but I don't have to cite.
No, you don't need to cite it. Yeah, exactly. Yeah.
And one last question. I see here the counter argument is up to 1,200 words. It wasn't like the counter argument and the review up to 500. Or they reversed that?
Yeah. So the counters are a bit longer.
Okay.
So the reviews are shorter, and the counters are sort of a short essay again, right? So it doesn't have to be 1,200, but it's sort of longer than a review, because in the review you don't discuss the merits of the argument, you just discuss the essay itself. Whereas in the counter you need to discuss the merits, and that usually takes a little bit more time because you need to sort of present your position, right? But those numbers, treat them as kind of upper limit, not as a requirement, right? So if you write a shorter counter, that's okay. Yeah. All good? Right. Thank you very much.